Welcome to another lesson. So this is a continuation from the Law 7, which I do appreciate. It was lesson number 72, but there was a miscount of a few lessons back. I think there were two lesson 71s. So yeah, you'd think someone who's teaching math could count, but you're proven wrong sometimes. So this is lesson 74. The last one was actually lesson 73, not 72. And so this one is all about circle theorem and circle theorem questions. So we'll be using kind of the stuff that we talked about last time, the proofs that we've done for circle theorems, and kind of applying them here. So what's important here is kind of just remembering them, and but yeah, let's get into it. So question number 1: B and C are points on a circle center O. AB and AC are tangents to the circle. Angle BOC is 130 degrees. Work out the size of the angle BAO. So one of the first things to do here is actually to draw in some lines as usual, because there's some lines of interest. So angle BOC is, what's that? That's from B to O to C, right? So if we draw that in, actually, I'm actually going to do this. Okay, so we have BOC, and we're looking for this angle here, I presume. BOC is 130, sorry, we're not looking for it, we were told it's 130 degrees even. 130 degrees. We're looking for this angle, size of the angle BAO. So if we draw that line in as well, we're looking for this angle here. And how might we do that? So we've drawn this in, right? We can tell actually that this is going to be a radius, and a radius meets a tangent, so that's 90 degrees. And we know this is 130 as well, right here. But if we, for example, if we know this is 90 as well, we can add that in. And if we use the other circle theorem, that when we have tangents and they meet the circle, they're going to be the same length. So this length is equal to this length. So we have a 90-degree circle with this, and this length is equal to this length, and this length is equal to this length. So that means they're congruent. So we know that they're congruent. So you'd kind of say, if they're congruent, then they're kind of the same, right? So that means that the angle here will equal the angle here. So then we can just divide that by 2. So this angle here is just 130 by 2, and 130 by 2 is 65. If this is 65, this is 90, and this is 90. So this is 180 minus 90 minus 65, which is, what is that? 25 degrees. So of course it'd be quite important to actually write this working out. I've kind of just talked through it, but it'd be important to write the steps bit by bit. In fact, why don't I actually go ahead and do that? So I can say, first thing I did was I said I drew the lines in. We don't have to do anything for that, but we can say OB is equal to OC, so radii, length of radii are equal. That's the first step to do. And we can say AB is equal to AC, tangent, so that meet at a point or equal. Sorry again, I'm just writing a bit quickly to save some time, and so you're not sitting here just watching me write stuff out. We have AB is equal to AC, and we also have angle OBA is equal to angle OCA. So radii meet tangent at 90 degrees. And then we have congruence, so triangle OBA is congruent to triangle OAC by RHS. And if we have that, then angle BOA is equal to 130 by 2, because we have that, from congruence we have that if this angle is equal to this angle, that it's equal to 130 by 2, which is 65. And then we have angle BAO, which is what we need. Angle BAO is equal to 180 minus 90 minus 65 is equal to 25. Angle in a triangle sum to 180. Another question we have: P, Q, and T are points on the circumference of a circle with center O. The line ATB is tangent to the circle T. PQ is equal to TQ. Angle ATP is equal to 58. Calculate the size of angle OTQ. O to T to Q. So we're looking for this thing over here. Again, give a reasoning for each stage of your working. So let's kind of get the information we have. We know PQ is equal to TQ. That's already in there. And angle ATP is 58. So they've actually given us that already. So that's kind of lucky for us. Another thing we have perhaps is if we look at this, it looks distinctly like the alternate angle theorem. Or not alternate angle theorem, but that kind of if this is a triangle and there's a tangent here, that this angle will equal this angle. So we have angle OTQ. If we say PQT is equal to 58. Angle PQT is equal to 58. And so the way you approach these kind of questions is, if you have a single piece of information, right, you just see what you can do with that. So the first thing I can straight away tell is kind of that this angle will equal because of just spotting that theory, or that circle theorem. So basically, it's a kind of fill in the blank exercise. You try to think about what you can do with the information you're given to kind of get closer to the answer. Sometimes you won't even know if it's a step closer to the answer or not. But if you can kind of tell for sure what an angle will be, it's worthwhile to kind of fill it in. Your life will just be easier. So angle P to Q will be that. So alternate angle, and then tangent. We have that. So we have this is 58. We also know that kind of a tangent meets the radius at 90 degrees. So we know that angle OTA is 90 degrees. So radius meets tangent at 90 degrees. And therefore angle OTP will equal 90 minus 58. Angle OTP will equal 90 minus 58, which is 32. And you don't really need a reason, that kind of follows straight from there. So I'll mark this in as well, 32. And it's important when you do mark this in, mark it in with a pencil in case you get something wrong so you can rub it out. And as you do this, you can do this, and then you mark it along as you go, basically. So we know this is 32, and now we're getting kind of closer to the answer, right? We know that this is 32, this is 58. So once we calculate this full angle, we can just do, once we know the full angle, we can tell what this angle might be here. And so it looks like we need to figure out what this angle here is. And it looks like we will probably get the answer. So now what we do is we think about a piece of information we haven't used so far. The piece of information we haven't used so far is that these two lengths are equal. And that means it's an isosceles triangle. So we know that this angle here is equal to this angle over here. So angle, TPQ is equal to angle QTP. So we can write that, in fact. So I'll continue on here. Angle QTP is equal to angle TPQ. Isosceles. So base angles of isosceles triangle are equal. If we know that, then we also know that we can say let angle QTP equal x, for example, and we have x plus 58 equals 180, and because angles in a triangle sum, interior angles in a triangle sum to 180 degrees. And if we have that, then we have 2x is equal to 180 minus 58, which is 122. So x is equal to 61. Is that it? Yeah, 61. If x is equal to 61, then we can say for something like angle QTP is equal to 61. That's because that's what x is. So, and we also have that angle, the one we're looking for, angle QTO, which is the one we're looking for, or OTQ, which is the same thing, is equal to angle, the big angle QTP minus this angle OTP. So equals angle QTP minus angle OTP, which is 61 minus 32, which is 61 minus 32 is, what is that, 29? So, you know, I did some mental math there. It's, you know, worthwhile checking your answer with a calculator if you've got a bit of time, and that's indeed the case. So, but in fact, I think I made a mistake up here. 180 minus 58. No, I don't actually. I thought I made a mistake for a second. So, you know, this is our answer, 29 degrees. And just, you know, there we go. So again, how I approached that kind of question was, even if I didn't know initially what to do, was I thought about, you know, kind of, let's look at a piece of information and see how we can apply it using some circle theorems, and just kind of fill in some blanks that we have. And I did that, and I kept doing that, and, you know, once I got to stage here, with I 58 and 32 filled in, I knew all I had to do was kind of find this angle, and I could find what this angle here was. So, you know, I thought then, what piece of information haven't I used that might help me out? Because, you know, from the 58 to 32 and no angle here, I can't really do anything. But from the two equal lengths, I could do something. And so I kind of, knowing that, and you move forward. So a lot of the time, it's, you know, again, as I said before, if you've given a piece of information in the question, they've given it to you for you to use it. They don't kind of give information for free. Like, it's there for a reason. So you end up having to use all pieces of information within the question. So question 14, this is supposed to be quite a tricky one. So let's try this. S and T are points on the circumference of the circle, center O. PT is tangent to the circle. Nice. You know, now that you see PT as a tangent to the circle, straight away what you can do is, you know, OT is the radius. You can just mark it 90 degrees. So that's a quick thing to do, actually, as you can do it as you read along. SOP is a straight line. And not only is it a straight line, we can actually tell it's a diameter because it's a straight line through the center. Or sorry, it contains the diameter at least. Angle OTP is 32. They've nicely, OPT is 32, and they've nicely put that in for us. Work out the angle marked X. Give reasons for your answer. So as you go along, you have to give kind of reasons. So, you know, now that I marked it 90 degrees, it's obvious to me that what this angle will be. This will be 180 minus 90 minus 32. So I can say, you know, angle, what is that, TOP, angle top, is equal to 180 minus 90 minus 32. And in fact, sorry, I should write before this, angle OTP is equal to 90 degrees because radius meets tangent at 90 degrees. So angle TOP is 180 minus 90 minus 32, which is 90 minus 32, which is 58, I believe. Let me check that. Yeah, 58. Ooh, that is quite badly written now. 58. So I'll mark that in, 58. Angle on a straight line, so we know that this angle will be 180 minus 58. So, you know, how did I know to go straight from there is because it's an easy thing to figure out. I've figured this out as 58. You know, I know it's a straight line. I can just recognize a straight line, right? And I know that will be the easy next step to do. So angle SOT, angle SOT is equal to 180 minus 58, and angles on a straight line sum to 180. So 180 minus 58, which is 58. What's that? I'm just going to do that on the calculator. See the time, 122. Oh, we actually did that calculation before it was on 122. And we also have, now that I know 122, so I know I have to find this angle out, and I can find out what x is because of a triangle thing. So knowing that this is 122, I think, you know, is there any piece of information I haven't used so far in the question that might help me? Not within this information here, but I know that this is a center, right? And whenever you see the center, think radius, because radius are of equal length, which makes an isosceles triangle. So angle TSO is x. So we can say angle, what is that? Angle TSO. Angle TSO is equal to x. Or we can, in fact, we probably ought to say, you know, OT is equal to OS first. So radii are equal length. And if you want to be really kind of explicit, in fact, what you do after this line is you'd say something like, because of this, then the triangle TSO is an isosceles. So triangle TSO is an, so that's in fact a direct implication, so you can have that sign, is an isosceles, if I'm spelling that correctly. And then you have angle TSO is equals x, base angles of an isosceles. Okay, and now we have x plus 122 equals 180, because angles in a triangle sum to 180. So x plus 122 equals 180. Angles in a triangle sum to 180. In fact, you should ought to say interior angles to be specific. And now rearranging this to x is equal to 58. X is equal to 58 divided by 2, which is 25 plus 4, so 29. And there we go. Same answers before, actually, funny enough. So, yeah. So again, as a quick recap, questions like these, it's basically a fill-in-the-blank exercise, and you write your reasoning for the fill-in-the-blank as you go along. So sometimes, if you maybe you're in an exam situation, you don't have a huge amount of time. Sometimes you don't know every move that you every blank you fill in is necessarily going to be helpful. So it's not always kind of useful to do it as you go along. So perhaps, as I did in this first question, actually, is I kind of fill in the blanks in my head and kind of go along in my head without writing the reasoning. If you've done enough circle theorems to kind of remember all that stuff. So if you do enough practice, you can get to a level where you can just do this in your head. But as you do it, you can kind of make sure that every move that you make is kind of the right one, I guess. So you kind of fill in the blanks, and then you get the answer. And sometimes there will be kind of angles that you didn't need to find, and so you don't need to put them in your reasoning. So you could kind of solve the question first, and then write it out properly. So solving on the diagram first, or if you want, you could kind of, as I did here, for example, especially when questions are perhaps a bit more complicated, it might be worthwhile to kind of go step by step and say, what the right angle is. Here we actually basically have to figure out every angle, right? So, you do something like that. You'd say what the first step is, etc., right? And that means that when it comes to working, you don't actually miss out any of the steps or any of the reasons, which you could technically lose marks for. So, there's the two different approaches, but basically it's a fill-in-the-blank exercise. Use a piece of information you have and the circle theorems you have to kind of combine them and fill in some form blank and keep filling in blanks to get your answer. So hopefully that all made sense, and I'll see you guys in the next video.